Good day and welcome back. Today we will be looking at trigonometry. Firstly, this will serve as an introduction and background knowledge to ensure that our toolbox is packed with the right equipment to be able to do well in this topic. Allow me to say, for those who wonder what 4IR stands for, the Fourth Industrial Revolution. What is trigonometry? Let's break up the word trigonometry in three parts. Gonia and metry, referring to tri, 3, gonia refers to angle, and metry, measurement. Or it could be interpreted as trigonometron, 3, side or edge, metron meaning measurement. Gon could also refer to polygon. When we refer to the alphabet of trigonometry, here we speak of sine, cos, tan, cosec, secant, and cot. All these are classified as different ratios that we work with in trigonometry. When we refer to the Greek alphabet, these letters and symbols are commonly used as angles. We speak of alpha, beta, theta are the most commonly known ones, and the one that a person would know from primary school already is pi. In trigonometry, we refer to three distinct things: a distance, a slope or a rise, and a height, from a level to a pinnacle. A vital component to understand in trigonometry is the following. If I stay where this teal color is situated, if that is my house, and this is a road, this is another house, then the house that is situated next to me will be known as adjacent to me. The house that is on the other side of the road will be known as opposite from me. But should I, however, have stayed here, then that neighbor would have been my adjacent neighbor, and that very same neighbor there would be my opposite neighbor. So relative to where you stay or your position, this could be adjacent or opposite. Adjacent to this one, but opposite from this one. And if this is your house, this one would be opposite from your house, and that one would be adjacent to your house. The first thing that we need to do when we work with right angle triangles is to identify the hypotenuse. And the hypotenuse is the side that is opposite the 90-degree angle. And notice how the 90-degree angle is identified as an angle with a little square inside. So the next thing, if my position is where the star is, the side opposite the star, that one is opposite the star, and this one is adjacent to the star. It is tied to the star and the 90-degree angle, right? If I'm standing over there, this side here will be opposite, it's loose from, and this one is adjacent to the angle concerned. So I can see a side will be opposite or adjacent relative to where I'm situated. Also in trigonometry, when we work with angles, we speak of the side opposite the angle as the small letter opposite the concerned angle. Opposite angle A, the side's name would be small a. Opposite angle B will be the side small b. Opposite angle C will be the side small c. So at this point, we all should be familiar with our different quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4 in an anti-clockwise direction. So firstly, I would like to construct a butterfly. And I say in this butterfly, I have x and y values and r for the radius of the circle in the different quadrants, and x and y is positive or negative relevant to the quadrant I am in. So if I look at this coordinate here, I will have a negative x and a positive y. So when I look at the information, I will see that all ratios are positive in the first quadrant, only sine and cosec is positive in the second quadrant, in the third quadrant only tan and cot is positive, and in the fourth quadrant only cos and secant is positive. We would all be familiar with sine being a y value over r value. Does not matter in which quadrant we are, but in quadrant 3 my y is negative, hence sine is negative in the third and the fourth quadrant. Likewise, cos is an x value over r value, and tan is a y value over x value. These things should already be consolidated and we should know these. This is pivotal if I want to solve trigonometric ratios if information is given. At this juncture, your special triangles also forms a part of your foundation for trigonometry. So if you do not know them, then you won't use them. Quickly refer to the 30-60 triangle. Opposite the smallest angle is the smallest side. Opposite the biggest angle is the biggest side. So 1, 2, square root 3 in the 30-60 triangle. In the 45-degree triangle, I have an isosceles triangle. Angles opposite equal sides are equal, and opposite equal sides I will find equal angles. So this hypotenuse is equal to square root of 2. Then a special triangle that is not commonly used is the 0-90 triangle. Zero elevation, so there's a height of 0. And because this is a radius and this is a radius, the length would be 1 and 1. Identities that should be in our toolbox is that tan of x is equal to sine of x over cos of x. From there, we can derive that sine of x is equal to tan of x multiplied by cos of x. And likewise, we can derive that cos of x is equal to sine of x divided by tan of x. Sine square x plus cos square x is equal to 1. And from here we can derive that sine square x is 1 minus cos square x. And cos square x minus 1 is equal to 1 minus sine square x. I hope and trust that this introductory video covers all the bases that you need to have in your toolbox in order to do well in trigonometry.